Okay, today we are going to find the first and the second derivative of a log function. Now, we're not going to use implicit differentiation, at least not actively. I suppose everything is implicit differentiation in a way, because when we derive the right side, we are deriving the left side in the sense that we're taking dy dx of y, which is dy over dx, which is the slope of the tangent line. But we're just going to worry about the right side today. So today we are going to have to apply the product rule first. So the first thing that we're going to do is apply the product rule. So we're just going to write dy dx of y is dy dx, this entire thing, times ln of x. All right, which equals, now product rule, okay? Let's remember that this is the product rule. With these kinds of things, it can be easy to do the wrong chronology. It can be easy to do the right thing, but do it in the wrong order. So we're going to write product rule. Okay, so we're going to take the square root of x times ln of x prime plus square root of x prime times ln of x. The first derivative isn't going to be too bad. The second derivative gets a little bit harder, but mostly what's difficult about this problem is simplifying it correctly. So now we've got square root of x times 1 over x, because the derivative of ln x is 1 over x, plus, let me put that in brackets or we're going to get confused, plus, now the square root of x derived is always 1 over 2x. It's 1 over root of 2x, excuse me, times ln x. Okay, excuse my weird looking n. Now the next thing that we're going to do is we're going to do a little side note. I don't know how obvious this is to people. Just a little side note right here. Side note. The square root of x times 1 over x is x to the negative 1 times x to the 1/2. And that is x. Now the exponents, when you multiply the bases, the exponents get added. So we're actually having a negative 1 plus 1/2 here, which means we're actually going to end up with x to the negative 1/2, and that equals 1 over x to the 1/2, which is the square root of x. So this is what we're doing right here, okay? Okay, so the next thing that we're going to do is we're going to just simplify this. We're going to just put ln x on top, no problem. So we're ending up with dy over dx equals 1 over square root of x times ln x over, oh, it's not times, it's actually plus. I made this mistake like 3 times when I first did this problem. Remember that this is plus ln over 2 square root x. Okay, so what do we do to add these? Well, we just multiply top and bottom of 1 over square root of x by 2. So we're just going to multiply this by 2 and this by 2. It's called the well-chosen 1, because 2 over 2 is just 1, so you're really not doing anything to the equation, really, right? So we end up with 2 over 2 square root of x plus ln of x over 2 square root of x. And that means that we really have 2 plus ln of x over 2 square root of x, and that is our first derivative. But we're not done, because now we're going to take the second derivative, and that's when things get more complicated. So the first thing that we're going to do here is we're going to note We're going to know just to remember, just so that we understand, that 2 times the square root of x is 2 times x to the 1/2. Okay, so now what we have is we're going to actually have dy dx of y prime, right? And that's going to be dy dx of our new formula that we just derived, 2 plus ln of x over 2 square root x. So what do? We use the quotient rule. Now, for those of you who don't remember the quotient rule, I'm going to write it down. First, let me just write quotient rule. Quotient rule. Okay, the quotient rule is that if you have f over g prime of x, that equals, and the best way to remember this, my professor taught me, is to remember what's on the bottom. It has to be squared, and it's also going to be the first argument on the numerator, right? So this is going to be g squared. And that's how you know you start with g times f prime minus f times g prime. And that is what we're going to use right here. That is what we're going to use. All right. So the first thing that we're going to do is we're going to just write dy prime over dx equals. Now we know that our first argument on the numerator is going to be 2 times the square root of x. This is going to get pretty long probably. I'm going to make it long. So we know that it's going to be 2 times the square root of x. And we know that 2 times the square root of x is going to be on the bottom, squared. Now, this is going to be multiplied by the derivative of the top. So 2 plus ln x prime minus 2 times the square root of x prime times 2 plus ln x. Okay, so that makes sense. It's just a lot of writing mostly. Now the really hard part is just to simplify correctly. So the bottom's going to become 4x because 2 times the square root of x times 2 times the square root of x makes 4 times the square root of x times the square root of x, which is just x. So I'm gonna put that below, otherwise I'm gonna run out of space. And I'm going to give myself another dividing line here. Okay, so now what we have is 2 times the square root of x times 2 plus ln x prime, which is actually 0 plus 1 over x, minus 2 times the square root of x prime. And now, like I said in the beginning, the note was that 2 times the square root of x is actually 2 times x to the 1/2. And so if we want to derive that, I'm going to actually make a little note up here. That 2 times the square root of x is 2 times x to the 1/2. So if we want to derive that, dy dx of 2x to the 1/2 is going to be 1/2 times 2x to the 1/2 minus 1, which is going to equal x to the negative 1/2, which actually is 1 over the square root of x. So now what we're going to do, I'm going to actually put that in some kind of boundary so we don't get confused. Okay, now what we're going to do is we are going to plug that in, and we're going to remember to put that in brackets. This all needs to be in brackets. We all need to remember that one side is being subtracted from the other side here. So this is going to be 1 over the square root of x, which is this right here, times 2 plus ln x. And that's all going to be over 4x. So now we're going to move over to the top right, and we're going to rewrite our dy prime over dx. And we're going to just start simplifying and rearranging because that's really all that's left to do. So we're ending up with 2 square root of x over x minus 2 plus ln of x over square root of x, all over 4x. All right, so now we're going to use this rule. Maybe you don't remember it. It may have been a while. I'm going to write it over here on the right. I hope I end up having space. I'm going to have to start a new page. That a over b minus c over d all over e is the same as AD minus BC over BDE. And that's just a rule. It's not actually hard to derive either, but if you just have to memorize it, that's fine too, I suppose. I always have an easier time just understanding why these things are the way they are, because then if you can't memorize it, if you forget it, you can just derive it again. It's very handy in an exam. So what we're going to do is we're going to treat this as A right here, this is B, this is C, this is D, and this here is E. So this is going to become the square root of x times 2 times the square root of x minus, let's put this in brackets, minus x times 2 plus L, and let me put the x on the other side or things are going to get confusing. 2 minus 2 plus ln of x times x over, I can do that better, I think. I can do that better using the tool. All over BDE, which is x times square root of x times 4x. We're going to simplify all of that in just a minute. The first thing that we're going to do is we're going to do probably some side work here, actually, to fix the bottom. But let's do the top first. Let's do the top first, and then we'll do the bottom after. Okay, let me write a line. Okay, the top becomes 2x, because square root of x times square root of x is x. It's like you could also make that the square root of x times x, and then you would have x squared in the square root, and it would maybe make more sense why that was like that, but minus 2x plus x ln x. That needs to be a negative, actually. That needs to be a negative because the negative is being multiplied through here and through here. So minus x ln x. And then on the bottom, we have 4 times x times square root of x. So the question is, what is 4 times x times square root of x? Well, let's do a little side work up here as well. Maybe I can make it small enough to actually fit this on the page. I'm not entirely sure. But we're going to basically, we're going to put in the exponents, right? And it's going to be, we're going to actually leave this x out. We're going to leave this x out. And we are going to just deal with these two. And we're going to say x to the 1 times x to the 1/2 is x to the 3/2, which is square root of x cubed. And what's interesting about that is it's a square root, right? That's x squared times x. And the cube root of x squared is just x. So we can actually take an x out of there. So this right here becomes, this one, and also we're canceling these out. This right here becomes negative ln x. And then once we've canceled these out, actually, let me just say that these are essentially in brackets, right? Once we've canceled this out, we can also cancel these x's, and that is why we left the x out. So the final solution is going to be, because we just did a whole bunch of work all at once, our final solution is going to be negative ln x over 4 times the absolute value of x times the square root of x. And the reason for that is that when we take out this x right here, when we take it out of the root, it just becomes x. But we don't know if it's a negative or a positive x because it's a square root. So whatever x would be, it would always come out positive. So that's why we have to make it the absolute value of x. And that is our solution.